Okay, hello everybody. Sounds like everybody's rolling in here. Um, yeah, happy Friday. I am Patrick DeZiel. I'm a engineer at Rotational Labs. Um, just a few housekeeping items before we get started. There will be a recording of this available, which we will provide after this talk. Um, and if you have questions, feel free to just ask them in the chat, and we'll try to get to them when we can. And Rebecca has also um, promised to try to stop between the sections for questions as well. But speaking of, it's my great honor to introduce Rebecca Bilbro, who will be our speaker today. And she is the co-founder and CTO of Rotational Labs. She has a lot of experience in tech communication and is the creator of a library called Yellowbrick, which is a Python library for model diagnostics for machine learning. And that very much relates to the talk today. She's going to be talking to us about how to get out of the sandbox and into the lab with respect to LLM development and AI development. So, without further ado, I'll let Rebecca take it from here.
Thanks so much, Patrick. Can everybody hear me okay?
Certainly can.
Awesome. All right. So I think we are all here today because we are excited about developing with AI. But I think the reality is that for a lot of us, AI development looks a lot like this. We are essentially playing around when what we should be doing is proper experimentation. So I want to start by introducing you to three characters based on uh, many real people that I have known over the last couple of years who are diving into this sandbox and who are doing their best to make it work. You have undoubtedly met at least one of these people before. They are all smart, they are all clever, motivated, and they are all working very hard and doing their best. But their experimentation is not working out. And I want to talk about why that is. So let's start with one who is particularly close to my heart. She is the overeager engineer. So if you have met her, you know that she is moving very fast and that basically no one can keep up with her. She was the first one on the team to dive into generative AI, and it feels like every week she is trying something new. You see her posting things on Slack and on Teams. She's throwing out tips for using Cursor. She's letting you know about the latest GPT patch notes. She's sharing the best new prompts from Reddit, and she's so helpful too. So whenever a teammate hits a roadblock or gets discouraged, she throws out suggestions. Try setting temperature to 0 or use this system prompt. It works good for me. Her enthusiasm goes a long way. But beneath all of the momentum is a blur of improvisation because her prompts are evolving midstream and they are not going back to version control. She is sharing her wins very loudly while her failures sort of get swept under the rug. And no one, really not even her, knows why things are working, but it does feel like progress. And it is until somebody tries to reproduce her work. The issue is that without documentation or reproducibility, her progress is fragile. But she's not the only one who is feeling inspired because Gen AI is pulling in people from all backgrounds, including a lot of people who have never written a line of code. So let's meet another character. This is the hopeful project manager. He is not an engineer, but he is deeply motivated to reduce manual overhead at his organization. So he's read all of the blog posts, he's watched all of the webinars, he's sat through dozens of vendor demos, and now he wants to show his boss that his team is ahead of the curve with AI. So he finds a tedious process, a tedious workflow, something that should be automatable. And he sets out to develop an AI assistant to replace that manual workflow with an agent. But he has no training data, no evaluation criteria, and really no spec. But his prototype kind of works sometimes, maybe. But his excitement is real, and his initiative is real too. The issue is that without a clear definition of what good looks like, it's too hard for him to tell if he's making progress. Without like a frame for his evaluation, he can't tell if the AI is actually better than just having human assistants do the work. But the reality is that when somebody like the overeager engineer or the hopeful project manager make a bad bet, the stakes are fairly low, relatively speaking. But when an exec does it, it can sink your entire roadmap. So this third character is the exec who promised too much. And I hope that this is not you, because this is a really uncomfortable place to be in. So, potentially you've met somebody like this, brought in to lead AI strategy at a company that has decided to go all in on generative AI. She nailed the interview. She's charismatic. She has a vision deck. She's empathetic. She's also got this bold roadmap that includes things like total automation of the customer support triage system and all kinds of agents and chatbots. And the reality is that she does have some experience. She's a little bit more technical than the hopeful project manager, because at her last organization, she'd had some success using, open AI wrappers to do a lot of automation. She assumed that would scale, but it's not working out. So the issue is that at her new organization, the infrastructure is way more complex, and also the expectations are a lot higher because she's sort of come in to totally change this organization. So in the rush to move as fast as possible and show progress to her boss, she pushes the team to begin agentic development. But she hasn't given them a clear problem statement, and there's no hypothesis or plan for evaluation. So now they're a month in and the momentum has totally stalled, and she is stressed because she is definitely not the only one at this organization who believed in the promise of AI, but she's going to pay the price if things don't turn around. These stories, I think, sound familiar because they all share the same fundamental problem that I think we can all relate to, which is that playing around, testing things out, is not the same thing as experimentation. So, before we talk about how to do it right, I think that we should take a really honest look at ourselves and say, what does it look like when we are doing things wrong? What does it look like to be a bad data scientist? So these anti-patterns are everywhere. I'm not calling anyone out in particular. These are things that I have done wrong in the past. Most of us have probably done at least one of these. Let's start with the most common mistake. So I think this is the number one anti-pattern that I see. And I think that it's the most dangerous because if you do not have a hypothesis, you're sort of dead in the water. So this is kind of what it sounds like. You'll hear phrases like, we're building an autonomous help desk, right? This is sort of probably what the exec who promised too much said, or we want to use AI to do this, or we're going to use AI coding assistants to accelerate our engineers. These sound like strategies, right? But what they actually are conclusions that are disguised as goals. They're assumptions. They are making assumptions that AI will be capable of doing these things before that's actually been proven. So what's missing here is the question. What are we trying to learn? What do we hope? What do we believe the model can do? How would we test if it is actually successful? So instead of jumping into the implementation, you have to start with a testable hypothesis. So this needs to be something sort of concrete. If you have done science before, or even if you've written OKRs before, you're probably going to be familiar with some of this kind of language, right? We suspect that a summarization model can reduce L1 support tickets by 30% if we integrate it in, right? That's measurable, that's testable. That's something we can evaluate. If you don't start with a hypothesis, though, your experiment is not going to be guaranteed to teach you anything. But the second most common issue is even if you do start with a question, it won't get you very far if you change everything at once. So changing more than one variable at a time is very, very common. It sounds like a success story usually, but it's actually a trap. And I'm going to tell you why. So you've probably seen this happen. You have maybe an overeager engineer who comes to you and says, listen, I changed the model. I upgraded it to GPT-4 Turbo. It's the latest. I switched out the RAG with a summary only step, and I've tweaked the prompts, and it already looks great. Or, I'm not sure what fixed it, but it's not broken anymore. um, you know, you've changed everything at once, so you don't actually know which change is responsible for the improvement. And the only way to reproduce that success in production is to keep everything, right? Like even the unnecessary stuff. So what that is going to translate to, if you do make it to production, is higher deployment costs, probably more application latency, brittle systems, and really just no clear path to get better. So what you have to do is you have to really trust in the scientific method, right? Change one variable at a time and start simple, right? Don't start by swapping out the model, which is the most expensive piece probably. Start with the prompt engineering part. That's the cheapest piece. And then kind of progressively test different variables in order of expensiveness, starting from cheapest rather than most expensive. So if you change everything at once, you will not be able to guarantee optimization, and you are likely to end up overpaying for your solution. The other issue that kind of is related to this is that even if you get to a solution that feels like it's working, it's really hard to tell if it's good. And this is related to something that I think probably is one of the trickiest things that has been emerging in this conversation, which is how do we measure success with generative AI? Because accuracy feels like an intuitive concept, but it's not when you try to measure it with generative AI. So usually I'll hear things like this. I'll hear people say, oh, with this prototype, we're going to target 90% accuracy. Or, next sprint, we're aiming to have for the model to get the answer right, twice as often. The issue is that generative AI is not the same as traditional machine learning, right? So traditional supervised learning has a very well-defined mathematical definition of accuracy, and that doesn't hold in generative AI because it's not about correctness, it's about alignment, it's about whether or not people like it, people feel like it's good. And that's subjective. So mathematical accuracy is actually not particularly relevant in a lot of these cases, because you could even get outputs that look technically correct, but they don't feel right to the user, right? They feel cold, they don't feel right for customer service, or maybe they don't feel specific enough to the domain experts, right? So it's much more complex than something as simple as like a mathematical computation of accuracy, and that's intimidating, because I think a lot of people coming into this do not have very much experience with qualitative analysis, but you really do need to learn how to do qualitative analysis if you wanted to do good generative AI solutions development, because you need to figure out how to quantify qualitative things. What does good look like for this specific user or for this specific stakeholder? So there are a ton of tricks sort of from the social science qualitative mixed methods tradition here. I've listed a few here, and I'll talk a little bit more about Likert scales later on. But this is a way of kind of trying to bring structure to qualitative measures. It's fuzzier, it feels a little bit weird. If you've done unsupervised learning like clustering, you'll be ready, because unsupervised learning is also kind of experimental and fuzzy. But with Gen AI, this is a more honest way and a more useful way of assessing efficacy of models. It's not about being correct, it's about being aligned. So I'm going to pause here. We're into a couple of our anti-patterns. I'm kind of curious if anybody has questions or has noticed any of these so far, and then we can kind of go into a couple of more anti-patterns that I think are getting more and more common. So first, any questions, Patrick?
Yeah, I have a question. So, how do you feel about the idea of open-ended versus closed-ended responses with respect to the measuring accuracy? Because couldn't you have a model which or an AI that produces a structured response that's is like only one of three things, for example, for like a classification example, rather than having an open-ended response? Does that impact this um, assumption of alignment here?
I think that I really do think that my experience working in unsupervised learning, kind of in the old machine learning days, has been really helpful to me, because a lot of times in the old days when I was doing text classification, in the beginning, you actually don't have the categories. You don't know the categories a lot of times a priori, so you have to discover the categories first, and you use unsupervised learning to get to those. You sort of use the open-ended step to get to the categories. And once you know the categories, then you can do more structured evaluation. So I think that works also in the generative AI application space. Like you usually have to start by discovering the categories, or you have to figure out how to break the space down a little. You have to discover the structure first. And having something sort of open-ended to say, oh, okay, I see. There's sort of like, there's good, there's bad, and then there's meh. So there's 3 categories, or maybe there's 5 categories, or maybe there's 10 categories. But a lot of times you don't really know that at the beginning. So early experiments do benefit, I think, from more open-ended testing. Great question.
Oh, I have another question from somebody. Can you ask? They're wondering if vibe coding is contributing to or hindering successful LLM application development.
Yes. Yeah,
Both of those things.
both. I mean, I think actually this is potentially a very good segue into my next slide, which is that alignment gets easier when you collaborate with other people. So I think the main problem with vibe coding is really just that you're working alone a lot of the time. So this is not really about tech, it's about kind of habits. Um, So if it's okay, I think maybe I'll answer your question by kind of diving into this next one since it's really relevant here. So vibe coders, I think, are usually guilty of this one, right? Like you run experiments, you try a dozen different prompts, and eventually the 12th one works. You ship it, it's done, but the catch is that nobody knows what you tried. The first 11 prompts are lost to time. Nobody saw the failures that came out of those first 11. Nobody saw you kind of going back and forth in a loop with Claude for 3 hours trying to get it to debug one little piece, right? So nobody is documenting those failures. And you have sort of an incentive as a vibe coder to hide those things because you want to celebrate the win. But the problem is that means you are not documenting your process, and even future you then is going to struggle to learn and reproduce what you've done. So this is basically what happens with the executive who promises too much, right? Like they have this intuition that something will scale because their initial small experiment worked out. But when the rubber meets the road and you're kind of in a huge infrastructure with really messy data that's extremely high throughput, and the schemas are evolving, and there's spiky behavior and application latency, all of that stuff kind of comes apart. So I think the takeaway is that like vibe coding alone is not bad. It's that being alone means that your experimentation is happening in a vacuum. And that means it's fragile. So yeah, I mean, I guess to me, the lesson is experimentation is a team sport. Does that answer the question?
Yep, that's a great answer. I have another question in the chat, which might be a little playful, but is what if you want your users, what your users want objectively wrong answers? Is that still a valid definition of alignment because you're aligning to what your users want?
It's humorously phrased, but like for my notes, you're talking about with generative AI, with accuracy, making sure that we're aware, kind of some of the ambiguity here. If it's not about correctness, if it's about alignment, and if some of the answers from generative AI are non-deterministic. What if, like, I'm like, for example, using a generative AI to build like, some kind of like, medical assistant or something like that, and users describe their symptoms to it, and it tells them they're great. And they don't need to stop drinking soda, and if anything, they should eat more chips and more donuts, and everything will be fine. And they love hearing that. What about that kind of dichotomy between stuff that, we know might have certain, a subset of answers we might be able to define as accurate, even if we can't define kind of the global sort of metric there. How do you balance those two constituencies?
That's a great question. And I think that the answer is don't work alone, right? So if you only have one person who is defining what good looks like, and it's somebody who loves soda and chips, the AI is going to tell you that soda and chips are great.
Okay.
Um, so you have to have more people on the team, including people who like broccoli and water and steak and all of the other things, right? You have to
Walking uphill and everything, yes.
you have to crowdsource truth in that case so that you're not thinking about just the individual end user, meaning like maybe the patient who's asking for health advice, but the stakeholder here includes patients, like the doctors, maybe the families of the patients, right? So it includes a lot of other people, probably the lawyers that work at your company that want to prevent you from getting sued for giving bad advice to people, right? So there's actually a lot of stakeholders there, not just the end user.
And this collection of perspectives can help you to have a better a definition of alignment that might help you get to a better definition of what you're actually targeting. Cool. Thank
Precisely. Precisely. Yeah, I think that one of the other things that I want to suggest, well, we'll talk a little bit more kind of specifically about preference-based scoring. So I think what I'll do now is let's talk a little bit about how you can kind of misstep by even if you are doing experiments that appear to be working. And the misstep here is potentially a little bit subtle, but it is, and it's very easy to make this mistake. It's also very expensive to make this mistake because it actually relates to intellectual property. So speaking of lawyers, this is an intellectual property challenge, because if you are not logging your prompts, if you are not documenting how your prompts are evolving and changing over time, if you're just kind of experimenting in an LLM playground or testing things out in notebooks, and what you do is you try something and then you tweak it and you tweak it and you're just overwriting it each time and eventually it works, that's actually not success because you don't know which change contributed to that successful outcome. And you've thrown away all of the previous versions of the prompts. You don't have a record of what model you used, what version of them, because the versions change all the time. You don't know what the system prompt was at that time. You maybe haven't recorded like what the latencies were. There are a ton of little components that are necessary for us to be able to explain what worked so that we can reproduce it. So back to the issue of intellectual property, a lot of legal precedent is being set now that suggests that your prompts are your IP. And so the reason is because those prompts distill business logic at your organization. And so you actually have an additional incentive to protect that IP. So my advice is to, treat it like code, treat it like it's worth something. Keep a change log of how things are changing over time. Document, for this experiment, we used this prompt, we used this model provider, we used this model version, this was the timestamp, this was the token usage, this was the latency, this is what we got back. Name each of your prompt variations, right? So this is like going back to college when you had like, history essay underscore final, right? So name them in ways that will allow you to reason about the evolution of those prompts over time and will allow you to reconstruct a timeline of your experiments. And look for tools that help you track those things. There are open source tools, so you don't have to pay money for this. Remember that the goal is not just build something that works, right? This is software. You need to build things that other people can trust. So unrecorded prompts are not just undocumented risk, they're also a lost asset. So the next anti-pattern that I want to talk about, I think, is maybe the hardest habit to break. And when I tell you about it, I think it'll make sense why. It does come down to kind of like human incentives. So this is, in my opinion, where many experiments go off the rails. Basically, if you make the evaluation plan after the experiment is already over and you've already retrieved the inferences back from the inference server, then your experiment was not designed to be evaluated. And a lot of times the problem is that this starts off sounding really innocent, like, let's just try it and see what happens. And maybe like the first time you send prompts to your inference server, that's acceptable. But if you do this routinely, what happens is you get back outputs and you realize that you never agreed on what good means. So now you're trying to retroactively justify the experiment, which is dangerous because that means you have an incentive to layer in your own feelings on top of the experiment, which is a risk to your organization. When you don't define success in advance, you risk wasting cycles. And I realize that this is really hard because people don't want to define success in advance and then meet failure. But the issue is that failure is what teaches you which direction to go in. So if you don't give yourself the opportunity to fail, you will likely not end up with the most optimal solution. You have to think about, what does good evaluation look like in the context of the problem that we're trying to solve here? And you have to start before you run the test. You have to define what success means, and you have to accept that some of your experiments are going to fail, but that failure, it's going to teach you something important. It's going to be like a bright, glowing neon arrow in the right direction. And your last evaluation is going to directly inform your next hypothesis. And I'll show you kind of a diagram of how this works in a few slides, but this is how you build momentum. It's not about what you do. It's not just about what you do at the end to kind of make meaning out of the results. It's about designing at the beginning. So I think maybe I will do my last anti-pattern slide, and then I'll take another pause for questions. So if people are having questions, maybe get ready, but hold for just a second, because this next one I think is probably the most irritating and insidious one, which is cherry picking. So cherry picking, I think a lot of people justify it for the same reason that they sort of will run the experiment and then do the kind of come up with the evaluation criteria after the fact. It's because you already have an opinion of how you want things to go, or you are inappropriately influencing the experiment. It might feel like you are being persuasive, but you're actually misleading people. So this can kind of look like being overly positive, or also being overly negative. Maybe saying something like, look at this crazy hallucination, sending a screenshot of it to the exec team to show that AI is, stupid, or, one single amazing output that gets passed around to show that AI is magic, and it can automate everything. The problem with both of those is that they don't actually represent the model's average behavior at all. They're outliers, they're extremes. So it's tempting, to kind of pick anecdotes to justify the time that you've spent, or your personal intuition or your personal feelings. But when you cherry pick, you are trading evidence for performance. And that mindset can lead to costly mistakes. Like, you might lead your team to overinvest in something that's really brittle, or maybe walk away from something that's really promising because they didn't really get the full picture. You have to show the good and the bad. So my suggestion is to, when the results come back, go through all of them, come up with a coding scheme. And when I say coding here, I mean data coding. So I'm talking about a qualitative methods approach, where you're kind of looking at text, you're looking at themes across all of the model inferences that have come back, and you're going to look for those themes so that you will be able to analyze and interpret them and reason about them. So for example, let's say that you have this kind of customer service application that is trying to triage tickets for the help desk, and you test it out, and you look at the results that come back, and you see that in many of the cases, the model appears to have misunderstood the category of problem that the user is having. So that is powerful, because now you can say things about the entire experiment. You can say, The distribution, you can talk about in 17% of the cases, this is what's going wrong. That is actionable. So that is the arrow that points you forward. It might feel like failure, but it's actually success because it's given you a clue. So like, why is it misunderstanding the intent? Like, is it because we don't have a category for that? Do we need to discover a new category? Do we need to make this a little more open-ended? It gives you a way to move forward. The other thing that it does, and I think that this is really critical, is that it normalizes sharing imperfect results, because you want to create a culture where learning is more important than posturing, right? You want to solve problems. The goal is not to prove that we're right and that we always know everything, even though that would be great. The goal is to learn what's actually true. Okay, so in the next section, I'm going to actually give you some suggestions that are very concrete about what you can do to design better experiments, but I think I'll pause again to see if there's any questions from Patrick.
I had a question about, do you have any recommendations for open source prompt management systems or version control systems?
I do. Patrick, do you want to drop a link in the comment in the chat? You actually, Patrick developed a solution for this for rotational that we use. It's a fairly straightforward open source package that you can easily integrate. But yeah, it keeps basically just keeps a log of all of your prompts over time together with any metadata that you want to keep. So, but you could do the same thing in an Excel spreadsheet. But it does help to have software that you can integrate, but it doesn't you don't have to overcomplicate it. You just have to document stuff.
Yeah. It's more about the active logging, which you talked about earlier, but it is definitely an important step in that process.
Yeah, I mean, if you're doing it in Excel, the risk is that it depends on a manual process of updating the spreadsheet. And, the reality is that manual processes are sort of fallible because maybe somebody forgets to update it or they're at the beach or something like that, right? But so kind of having some sort of automated way to do that, I think, can be really powerful. But the main thing is just to keep a record. Any other questions? How are we doing on time?
Yes, we just got another one. So this person is a non-coder, but they want to vibe code in a demo capacity to show how an idea would work, and not necessarily that would work in all aspects. Do you have any advice for them?
So I think so. It sounds like the goal here is really just to maybe dip a toe in the water. And I think that that's totally fine. It's okay to dip toes in water. It's okay to be in the sandbox. There's no problem with playing, right? Play is part of what we do. It's part of our humanity as people. It's how we learn. So there's nothing wrong with play. The issue is that if you're working at a company, you're on company time and you need to deliver viable results, you can't play. You can't just play. You have to build trustworthy experiments. All right. I'm going to move forward, but there'll be more question time at the end. So now that we've seen kind of what not to do, let's talk a little bit about how to design better experiments. I think that the key takeaway here is that good AI experiments are designed. They're not improvised. So the cheapest, most powerful tool in your arsenal is always going to be prompt engineering. So this is actually something that surprised me And I have it first because it was the one that was most surprising to me as somebody who's been doing machine learning for 15 years. When I shifted from doing traditional machine learning applications development to AI applications development, my intuition was that the best way to solve very domain specific problems, let's say, building, some sort of chatbot, like the doctor, eating advice chatbot. Let's say that's a, kind of fairly domain specific thing where the language is about, nutrition, let's say. So my intuition would have been, well, the best way to get a model that really understands nutrition is to take a big open source model like Mistral or Llama or something like that, and then to do targeted fine tuning to get it to relearn the distributions for words like soda and chips and broccoli and steak and coffee and all of that. Because you want the model to be attuned to the language of nutrition. So my intuition would have been that the fastest way and the best way to do that would be through fine tuning. But one of the things that I have been learning, and this is not actually a plug, but I do really recommend this book. I have no financial incentive to recommend this book, just so you know, but it's become kind of like a Bible to me. So this is Chip Huen's AI engineering book, and one of the things that she says in this book, which actually just came out this year, right? So this represents kind of the cutting edge, and she is very much like a Silicon Valley person who really, really knows. She's an insider, so I think you can trust that she knows. And really what she says is that you should always start with prompt engineering, because it solves most of the problems and it costs a lot less than fine tuning. So this was a little counterintuitive to me, but this is the current best practice for getting to the best solution, which is great news because it's also much cheaper than doing fine tuning and faster than doing fine tuning. In most cases, there are still cases where you do have to resort to training a custom model or fine tuning. So you can't always get there through prompt engineering, but you should start there. If you are finding that your experiments are failing, my best suggestion to you before going to fine tuning is to do task decomposition. I think that a lot of times experiments fail because we're expecting the LLM to do too much at once. We're sort of assuming that AI agents are like people, where you can give a person a problem and they can sort of break it down and, okay, I'm going to do this first, and then I'm going to do this, and then I'm going to do this, and then I'm going to do this. But you have to actually break the steps down. You have to break the steps down and then give the individual steps to the AI. You cannot rely on it to break the steps down, because this is where most failure would happen. So let's kind of go back to this hypothetical like help desk triage application that we've been spitballing here. So let's say the goal really is, somebody calls the help desk and says, my printer is not responding to my computer. And what you want is you want to be able to give a suggestion or a solution to that end user without having to go to the L1 help desk, which is the human help desk, which you do always need, because you always need humans in customer service. You cannot get away without that. I'm sure that you have all experienced like fully AI chatbot driven customer service, and it does not work. It sucks. So you keep the human L1 help desk, but maybe you have sort of this agentic piece that's trying to take care of like the 30% of cases that are pretty straightforward. So you have to break it down into pieces, right? Don't just tell the AI, if the customer asks this, compose a response to help them. You have to sort of break down the stages. Well, step one is, what is the problem? What's the customer's intent? That's a classification problem. That's a classification task. And I'm using the word task because that actually has a meaning in the AI engineering community. Like a task is a AI LLM task. So options are things like classification, translation, text generation, text summarization. So those are tasks, right? So you kind of break these tasks down, and if you can break them down, you can test them independently, and you can figure out where the breakdown is happening, and that will get you to success much more quickly than sort of reverting to something expensive like fine tuning. So this is something you can do purely with prompting and elbow grease. And I feel like we have to come back to this point, which is that AI experiments get better when more people are involved. I think it was Nathan who asked this question, like, what if you end up with a solution that just tells everybody to eat junk food all day? The solution is to get more people involved, get more eyes on it. Collaboration is going to make your experiments more robust, and it's going to make your evaluations more meaningful, and your eventual results are going to be more trustworthy. So I think that this would be a good time to talk about, like, how do you translate between like the sort of qualitative feeling of like, I like this or I don't like this response. How do you translate that into kind of directive feedback that you will be able to use to iterate? So this is an example of Likert-based scoring. So in our sort of hypothetical help desk application, let's say the agent is being directed to address this support ticket, and first to kind of identify the intent, and then figure out a solution, right? So in the first response, the model says, oh, try resetting your password. But the user has said, I tried that. I tried it 3 times, and now I'm locked out. And so that's a bad answer from the model. So we give it a score of 2. This is a Likert scale where 1 is the worst and 5 is the best. And you can kind of create your own scale, but 5-point scale is what we tend to use. And it's really helpful because it allows you to have kind of these ordinal ways of distinguishing between a poor response or a mediocre response and a really good response that understands that you are locked out of your account, and that what you really need is a way to unlock your account and then reset your password. So this gives you a way to, even though in Gen AI there is no single right answer, this gives you a way to quantify the better ones. So once you've defined what good looks like, the real problem is searching for it. And I think this is, if there's one thing that you walk away with from the talk, it's that AI development is a search problem, and it's a high-dimensional search problem, because finding the best solution for your application is a combination of a bunch of different things, like the system prompt and the user prompt and the model provider and the version, and just a lot of different things. And all of those come together in kind of non-deterministic and unclear ways to produce the effect. And so if you are just doing random tinkering, you might get something to work, but the probability that you get to the most optimal solution or the most cost-effective, most maintainable solution is almost null. So it's a search problem. You need a strategy. And this is what we use. So this is the system that we use at my organization, Rotational, where we do kind of consultative AI solutions development. So this is the workflow. You start by defining your question. What's the problem? Then you take that and you turn it into a testable hypothesis, something that you can either prove or disprove. Then you select one variable to test. So maybe that's the model, maybe that's the prompt. I hope you start with the prompt, that's cheaper. But you could change the context. So you can pick one thing to change at a time, then define how you're going to evaluate what does good or bad look like. Once you know that, come up with test cases, work with domain experts. The best thing that you can do is create test cases that are labeled. So this is what good looks like. If I ask the model this and it says this, that is good. If I ask the model this and it says this, that is bad. And so having those labeled test cases at the beginning is incredibly helpful. But then you send all of the prompts to the inference server. And then what comes back needs to be qualitatively coded. And again, coding here doesn't mean like software programming, it means qualitative coding, looking for patterns in all of the responses. Once you see the patterns, then you do your analysis and interpretation. You try to understand, what were those patterns? Why do we think those happened? Is that because is it a needle in the haystack problem? And then you have a new question. And then it starts over again. And I realize that this might seem counterintuitive, that science will speed you up, but I promise it will make you go faster. And it will also help you build better solutions when you follow this structured process. So let's recap, and then we might have, I don't know if we'll have, let's see, we'll have maybe 5 minutes for a few last questions. So curiosity is great. It's a great start, but if you want real results, don't guess your way there. Bring the structure, build trust with real, rigorous, robust experiments, and then you will get to the ROI. Thank you so much for coming. If there are any questions left, I would be happy to take those now. Otherwise, have a great weekend and happy experimenting.
I have a question. How do you go about creating test cases? If you're like, let's say you're creating a model for somebody else, like how do you create test cases for them?
Such a great question. Yeah, I mean, I think that the reality is that in a lot of cases, people are going towards AI solutions development because they don't have any training data. And so if you don't have like a wealth of training data to train a custom model, that's when an AI model would be really attractive, because you can kind of like, you can get started with something, even if it's sort of mediocre to begin with. But the reality is that if you don't have training data, what you do need is test cases that are specific to the stakeholders. And hopefully you can kind of you can use that framing to help communicate to your stakeholders that without their help in at least curating or helping to create test cases, the reality is that the solution will always be mediocre. So you definitely do need to work with the domain experts. I think that it can be really helpful to show people things that are bad, because people enjoy reacting to bad things, especially domain experts, because they're very attuned to their domain and they will tell you if you have it wrong. So one way to maybe get the ball rolling is to say, well, let's say we asked the model this and it said this. Is that a 1, 2, 3, 4, or 5? So you can kind of get the ball rolling there, and then you could say, well, what does a good example look like? And then you can kind of, work from the extremes kind of inward. So that I think that strategy has worked for me. Thank you all so much for attending. I'll see you around.
Thank you very much for the wonderful talk.
Thank you.